Yeah, good morning, guys. So this is today's LeetCode streak problem. So the problem is maximum number of K-divisible components. So let's read out the problem description. This is an hard problem. There is an undirected tree with n nodes labeled from 0 to n minus 1. You are given the integer n and then 2D integer array edges of length n minus 1. Okay, where edges of I is equal to a of I and b of I. Indices that there are in an edge between node ai and b of I, which is there will be an tree which is of n nodes, and nodes are labeled from 0 to n minus 1, which is if there are 5 nodes, the name of the nodes will be 0 1 2 3 and 4. If there are 6 nodes, so 0 1 2 3 4 5, which is they are saying it as 0 indexed tree. Okay, and you are given a integer n and then 2D integer array edges of the length n minus 1, where edges of I is equal to a of I and b of I. Indices that there is an edge between node a of I and b of I. Okay, so this is the edge they have given. Okay, so let's say they have given 5 nodes, which is 0 1 2 3 4. So this is 0 1 2 3 4, 0 1 2 3 and 4. Okay, now what they are saying is they are saying in this edge they are giving the edges in the tree, which is from 1 to 2 there is an edge, from 1 to 3 there is an edge, and from 2 to 0 there is an edge. So this is n minus 1 edges will be given to you. Okay, and after that you are also given a 0 indexed integer array values of length n, where values of I is the value associated with the ith node and an integer k. Okay, let's see this integer k later. Now we'll deal with this. So they will be giving a value array which has the value of the node. Okay, so this is an like 0, this is the 0th indexed, let's consider this is the 0th indexed node, this is first indexed node, this is second indexed node, third indexed node and fourth indexed node. But this node can possess some values, right? And those values will be given in the array called values. So for index of 0, the value will be something. So the value of index, so the value of node 0 is equal to the array value of index 0. So for 1, array value of index 1. So the value array of 2, 3 and 4. Okay, and an integer k. So this k have been given. A valid split of tree is obtained by removing any set of edges, possibly empty, from the tree such that the resulting component all have values that are divisible by k, where the value of a connector component is the sum of the value of its nodes. Okay, return the maximum number of components in any valid split. Okay, so now what they have given is they have given the value of k, they have given the index of these nodes, and they have given the values of these nodes also. And what they're asking is they're asking you to split this tree into different components, and if you sum up the value of those components, you need to get the number that which is divisible by k. Let's consider here. Let's take this example. They have given 5 nodes, which is 0 1 2 3 and 4, example 1, and have given edges. So these edges and values, so this is the value. Now let's do here. So 1 comma 8 comma 1 comma 4 comma 4. Okay, this is the value they have given. Okay, this is 0 1 2 3, which is 0th index, 0 indexed arrays, right? Okay, so this is the valid split they have done. Okay, for 1 and 3. So if you sum up the value of 1 and 3, what you get is the value of 1 is 8 and the value of 3 is 4. Okay, which is 12. And if you, the given k value is 6, 12 is divisible by 6, right? Yeah, so then it is a valid component. And if you go for this has 2 4 and 0. Okay, now 0 plus 2, which is again 1, plus again 4, so which is value of 4. So if you sum this, you will get 6, which is divisible by the given k value. Hence these are the two components, two valid components. Okay, guys, so now we got to know how to create a valid component. Now let's so we learned what is valid component, and we need to divide it into different pieces, which is different components, as much as we can. Now how can you do this? So we can do this using a DFS method. So hence it is a tree. It has only two ways, right and left, but it is an undirected graph. So let's consider it as a graph now, okay, but it doesn't have a cycle. Okay, so for each node there could be max of 3 edges, which is its parent, its left and right. If you do a DFS, what happens is it goes to the last of 4, right? It goes to the 4, and in 4 it what happens is it sums the 4 and it checks whether it is divisible by k. Not, it is not divisible by k, right? And it returns the value of 4 to the 2. Okay, now it goes to the 0. Sorry, for 4 what is the value? Yeah, for 4 is the value, so it returns 4. If you go for 0, what is the value of 0? 1. So 1 will be returned. Now 2 will be having 4 and 1. What is the value of 2 now? Value of 2 is 1. Okay, so it has 4 from its left and 1 from its right, and it itself possesses value of 1, which is 4 plus 1 plus 1, which is equal to 6 here. So for this 6, if it hence it is divisible by k, yeah, it is divisible by k. Then what we can do is we can mark as it as an one component and return 0 to the parent. Okay, because we are splitting this as a component and returning 0 to parent, which means from left you don't have any value. So what happens is it returns 0 and it checks for this subtree or this sub component and checks whether, and what it does is it checks whether we can find any different components or not. Okay, this is how you will be approaching the problem. Okay, hope you got this problem. Now let's dive into the solution. So they have given edges of array, but we can create a adjacency list, so that will be more helpful for us. Okay, now create a list. Integer, so this is an array of an integer. Let's consider this as G, and new list of n. Okay, and what happens is now, so for int I is equal to 0, I is lesser than n, I plus plus, graph of this is G of I equal to new array list. So this is nothing but of initialization, which is declaration. Okay, and after that what we do is we take the values in the edges and we add it to the adjacency list. So for that, for edges, so we are taking the edges, so we took the edges. What we do is we say int this is start node, so s is equal to edge of 0, and this end is equal to edge of 1, right, which is start and end. So now what we do is we say g of u dot add e s dot add e, and g of e dot add s. Okay, and I think we can, for DFS we can create a different function. So we say DFS of graph comma, so it will be starting from 0, so 0 comma and -1 as a preview, and let's say there is an value, so let's say value, so values and k. So this value is the values array and this is k. Okay, so for counting number of this, we need an integer result. So this will be 0 initially. Now we will be writing the DFS function. Okay, so the DFS will be returning the what is this data type? Okay, it could be long. Okay, let's say it is long DFS. It gets the list. So this is G and comma int of S and int of end. So this will be the preview, which is the parent node. So let's call it as parent, and because the edge will be coming from the parent, right? So that's why. And we have the values will be given by the user, which means here from the compiler, and int k. Okay, so this is the DFS function. So now what we do is we need to calculate the result. So for long, let's say value of the tree, which is tree, is equal to value of that S, because if you are coming to this node, this value should need to be added, right? So this value is added, and then we will be going for further process. Okay. So for int of, let's say this is, okay, let's call it as this is end, which is this is U, which is this is yes, which is this is the start of this, and this is the parent, which is this P, and this is the end. So which is, these are the adjacency, in adjacency list these are the values which will be presented there, right? So which is for 2, the values which will be present in adjacency array is 0, 1 and 4, hence there 4 are edges. As a for our array we can say, so this is a parent, but the computer or the CPU doesn't know, the program doesn't know this is a parent, so we need to set a condition for that, but these are the kids. So for that we are doing this, which is we are like iterating to the every and if this end is not equal to P, which is if this end is not equal to P in the sense of if this end is not the parent, which means for 2 you will be having 0, 1 and 4. If it is not equal to 1, because it is not equal to parent, we can iterate, which is except parent we can iterate through the remaining one. So that is what we are saying here. Okay, if that is not equal to this, what we say is, we say 3 plus equal to DFS of G comma and this E comma, and for parent we will be saying that S and comma values comma K, right? And after this what you do is you will check whether the sum is equal to K or not. If that sum is equal to K, what you do is you simply say that it is an itself, it can be divisible by K, right? So that for that, if tree divisible by K equal to 0, so it is divisible by K. So what we can do is we can, so we had the answer here, right? So the result should need to be global. We increment the count of result and we return 0, because if this itself it can form a value which is divisible by K, for parent it should need to return 0, right? So that's why if it is not forming, we return the tree. Okay, and here after doing this, so we are counting the number of components. The number of components will be counted here in the result, so we return result. Okay, values, it is values. So it is a small typo error. What happens here? Okay, we return given here. I think the DFS also comes out. Yeah, by mistake I have done it this way. This could be fine now. Yeah, let's submit this code. Yeah, you can see that our result has been accepted. Yeah guys, thank you. If you like the video, so do subscribe and like and share our videos, and if you want any further videos, like check it our channel, and if you want any specific videos, do a comment, we will try to do that. Okay, bye.